Right, so next up we have Dr Alpesh Patel from the Dr Hadwen Trust. Alpesh has got a PhD in biochemistry from King's College London and is responsible for managing the Dr Hadwen Trust grant funding portfolio and aiding the understanding and dissemination of all of the Dr Hadwen Trust research outcomes. He represents the Trust at stakeholder and supporter meetings and also helps to raise the profile of the Dr Hadwen Trust externally, as he's doing today. So I'm delighted that Alpesh will be joining us as a speaker and look forward to hearing what you have to say.
Very much, everyone. Thank you very much for the invite to come and speak to you guys. It's very nice to see a large number of people in the audience. So, just a little bit of background about myself. I've worked at the Dr Hadwen Trust for 6 years now. I started there as the science officer, and just generally over the years I've sort of drifted into this new role of grants officer, but I'm still responsible for a lot of the science that goes on at the Trust and understanding and disseminating the science. That's a little bit of my background. So what I want to talk about is all the stuff that's been mentioned previously, but also just put it in a slightly different context to equip you with the knowledge and the facts and the understanding of what goes on and what doesn't go on as well, because it's very important to know what doesn't go on as well. So some of the things I'm going to say from the start, some of the things I say might sound a little bit controversial. They might not sound the right thing to say, but they are the facts of what goes on. So if anyone is offended by it, or if anyone's upset by some things I say, please come and speak to me afterwards. I'm not trying to upset or offend anyone, but I just would like to put it out there from the start, just in case. So what we do at the Trust. So just a quick overview of the talk today is to give you an introduction to the DHD, talk about some facts and figures, because it's always better to be armed with facts and figures. Because when you approach someone and have a discussion about something, the first question they ask is, well, give me some proof. So if we can give you some of that proof, then it makes it easier for you to not only understand, but also when you're talking to others, when you're talking to other people, to talk to them on a firmer level. Then what we do, why we do it, what we fund, and how you guys can help out. Can everyone hear me?
Yeah.
Yeah? Awesome. Great. So, who are we? Who is the Dr Hadwen Trust? The name really doesn't. Cancer Research UK is, everyone knows what they do, it's very obvious what they do. But what does the Dr Hadwen Trust do? Well, we're the leading medical research charity that funds and promotes non-animal techniques to replace animal experiments. That's who we are, that's what we do in a nutshell. It's all about biomedical research, but it is also hand in hand about replacing animal experiments. You could come to us and say, I know what the next cure for cancer is. I have got it in my back pocket, I just need some money to develop it. And the very next question we would ask is, how are you replacing the animals? If you're not replacing any animals, we won't give you any money for it. And that's our focus. It's not just about developing cures, understanding disease, but it's also about doing it in a way that means that others can't use animals to do something very similar. So we were established in 1970, so we've been going for quite a few years, so we kind of have a lot of experience of the field. We have funded over 200 research projects in that time. Just in the last 5 years, we've invested about £4.7 million into research projects, and those of you that are in the sort of science, medicine field will know things are just getting expensive. Yeah, to do science now is getting very expensive. And all of our money comes from charitable donations and legacies. We are not government funded. We don't get big pharma money. We don't get big industry money. There are people like you that live and work all day, and then they come home, they put their hands in their pockets, and they give us money. So all of the money, all of the 200 plus projects that we've ever funded, all of the 4.7 million we've funded over the last 5 years is because of donations from people like you. So from my point of view, I'd like to say thank you as well to any donators and supporters that are out there in the audience, to say thank you very much, because without that, I wouldn't be standing here. Without your effort, I wouldn't be standing here talking about what we do. So again, we aim to benefit humans. It's not just about replacing animals. The work that takes place has to benefit humans. With the development of more relevant and reliable science whilst replacing these animals. I will talk about the relevant and reliable science a little bit later in the talk. So, the first question people always ask is, do we need to use animals? And the answer, unfortunately, is yes. There are lots of reasons why we do need to use animals. Some of them are not quite right, some of them are legal, and some of them are just historical. So animals have been used because they're an established method. They're easy to keep. Yeah, people have hundreds and hundreds of years of experience of looking after animals. And very crudely, but the way you look after your pets at home would be the way you look after an animal that you're going to experiment on, in essence. So we know how to look after the animals. They're similar. That's one of the reasons a lot of people give, is they're similar to humans. And we can't perform research on humans in the same way. It's very hard to do, and I'm going to use a very poignant example, or a very crude example. There's a test out there called the forced swim test. And what you do is you take a rat, you put it into a swimming pool, a pool of water with a clear plastic platform in there. And it sits on this platform in the water. And then what you do is you remove that platform. And the rat has to swim and find the other platform. It's called the forced swim test. It's used for a lot of neurological research to find out whether things are going wrong in the brain. Now, you can do that. You are legally allowed to do that to a rat. You couldn't do that to a human. There's no way you would get any approval. So again, certain things you can and you can't do, but there are other ways of doing that research. I'm not saying that's a good example. That's the way we do research, but that's an example of a test that we couldn't do on a human. And we're not quite there. But there are other ways of doing that research to find the answer without doing the animal experiment. And that's what we do at the Trust. Also, sorry, at this point I should say, I know according to the official timetable, there is a Q&A session at the end, but if anyone does have any questions, I would much rather have a discussion now, because I'm very conscious of how much information there is in my slides, even after trimming it down. And sometimes you think, oh, I'll ask that later, and then it gets lost in all the other stuff that's going to come up. So please, if anyone has any questions, do just ask them. I'm more than happy to have a discussion with you now. Yeah?
So what is the reason we can't perform experiments on humans? What's the government ruling? Or
the Human Rights Act. You're not allowed to put another human under discomfort, distress. You are not allowed to experiment on certain things. There are lots of things you can do with humans. It's not like you can't do anything with humans, and there's a lot of research that we fund that does use humans. But something like a forced swim test, something like putting them in a restraint, and again, I'm being very crude because they're the easiest examples to use. Something like cutting open their brains and putting electrodes in to see whether sticking a bit of electricity through a particular part of the brain makes something twitch. You can't do that with humans. Yeah, so there are things we can do. There are lots of non-invasive things we can do, and a lot of the research is moving towards that. But things like traditionally, and I'm going traditionally meaning 15, 20 years ago, you couldn't do things like what they call microdosing studies. Like, how does this drug affect a human? You couldn't do that in humans because we didn't have the techniques to look at that. So you'd have to do that in an animal. If I inject this into their skin, does it cause them a rash? You couldn't do that in a human because it would be cruel to the humans, but you could do that in an animal. But now, people have developed the techniques where you don't have to do that. So that's kind of where it is. So, one of the things, the flip side to that, I should say that animals are used, and they're used quite extensively, but they're used here, if you want to think of it in a positive way, we do have in the UK one of the highest standards of lab animal welfare in the world. And one of the things is, and this is not me, Alpesh DHT, this is me, Alpesh, member of the public. If you have to do an experiment on an animal, where would you rather it be done? Would you rather it be done in the UK, where there's full disclosure, where there's full, people are responsible, there are full animal welfare centers, or would you rather it be done in a country which doesn't really care about the animals, that doesn't care? We've all seen the pictures, I'm not going to put the images in your head, yeah, but we know what goes on in other countries, and I'm not going to pick on any country. But would you rather the animal is looked after and cared for here, where there is a chance that it's looked after and cared for, or would you rather it happens somewhere else where you know it's not going to get looked after and cared for. And that's the flip side. That's one of the things that the pro-animal people will come back at people with. But hang on, the animal welfare standards are the highest here, and they are. As the DHT, we acknowledge they are the highest. That doesn't mean that we should use them. Human welfare standards are the highest in the world here. But that doesn't mean that we can just experiment on humans because we have the best resources, yeah, or the best welfare. But we do have the best, and it's something that we should not be proud about, but it's something we should know. Because the way we do things in the UK, other countries are looking at us to say, we should do it the UK way. We shouldn't do it in the other way, in the developing world way. Yeah, we should do it the UK way. Again, you can't, a lot of people think that animal experiments, a scientist just wakes up in the morning, goes into the lab and says, right, let's do some rat experiments, some mice experiments, some primate experiments. It doesn't work that way. Yeah, there are 3 levels of licensing. You have an establishment license. The place where the experiment takes place has to have a license to say all the systems are in place for us to care for the animal in the best possible way. Yes, we are going to slice its brain open and stick electrodes in it. Yes, we are going to do that. Let's not forget that. But when we're not doing that, it will be looked after. Yeah? Then there is the project license. So you have to have a license to say, I am going to do this. If I do something outside of this, I'm going to be in trouble. And then you have the personal license, the person who's actually going to do the experiment. So it's not one person, and I'm just putting the information out there. It's not one person takes an animal from start to finish. There might be 20 people involved in the care and experimentation of the animal. And each one of them has a defined role. And if they go outside of those defined roles, they're hauled up against the Home Office and they're fined, and the establishment is fined, and there are procedures in place to deal with these things. So some of the scare stories that you hear out there, and I'm not disregarding some of the scare stories and some of the things you might see out there, but it's very hard to do that stuff. Yeah? And again, animal research can only be carried out if there is no suitable non-animal alternative. What does that mean? It means if there is no regulatory non-animal alternative, if there is no scientifically valid non-animal alternative, and if there is no scientifically accepted no-animal alternative. And I'll come to that later because that's a very important thing, because that has changed. That's the important bit for us as the DHT and for you guys as supporters. That last bit is the important bit. Because of that change, the work we do, the way we do it, the help and support you can give us makes a huge difference. So, why do we need to raise these issues? Why do we need to raise these issues about not using animals? It has worked. Animal experiments have been taking place for hundreds of years. We can't say, and one of the things that a lot of people do try and say is animals have never given us any answers. And unfortunately, and it pains me to say it, but as a scientist, that's just not right. If animals had never given us anything, we wouldn't have any drugs at all. Because 100 years ago, 200 years ago, we wouldn't have had the techniques we have now to be able to do this. So animals, we cannot say, and please forgive me if I offend anyone, but we cannot say to someone, animal experiments have never worked. What we say at the DHT is, historically, animals have been used because there were no alternatives. Now we know better. We know that we should be humane, we should be human relevant, we can do things in a better way without the animals. And there are hundreds of reasons. If I go into the reasons why animal experiments are bad, we'd be here all night. Yeah, so I'm not going to go through it. But there are lots of reasons why animal experiments don't work. So if we know they don't work, let's do something else. If you're driving to somewhere and you know up ahead there's a roadblock, why would you keep driving down that road until you hit that roadblock? Why would you not take a different route to get to where you're going? And that's where the DHT is at. It's, you talk about doing the animal stuff, we're going to say, right, let's find another way. Let's find another route. Let's not just keep hammering at this one road, keep going down this path and saying, oh, it doesn't work, let's tweak it. It doesn't work, let's tweak it. Let's go somewhere else. So there is that aspect. There is the ethical issue. Animals' rights, more and more and more. People are talking about animals' rights. There was a thing just last year about in America, where a judge, as part of his sentencing, kind of implied that chimpanzees have the same rights as humans. And there was a huge uproar, because as soon as a judge says that, then you can't do any experiments on chimpanzees, because then they have human rights. And you can't do things to humans that you would want to do to chimpanzees. So there is a whole issue about animal rights. It's historical. How many of us here drive a car? Show of hands. How many of us drive a car that's exactly the same as the Model T Ford? Yeah? Even I don't. Yeah? How many of us have ever gone in a horse and cart? Forget when you're in India. Yeah, just for fun. How many of us have ever gone in a horse and cart? But lots and lots of people 100 years ago drove around in horse and carts. But it's historical. Just because we can drive around in a horse and cart, does that mean we should? And that's what we are at the DHT. It's just because you can work on an animal, because you can, does that mean we should? It's historical. When there was no other techniques, when we didn't have things like this and things like this, and we can develop all these new technologies, when we didn't have it, okay, fine. Maybe we had to use animals then, but now we don't. And so there is historical. Also, for those of you that are in science, you know, your supervisor tells you to do an animal experiment. You do it because your supervisor told you to do it. Yeah? But again, we can change that. It is expensive. If you think of those guys that have pets, yeah, it's expensive to look after an animal properly. And then you multiply that by how many animals you've got to look after. It is expensive. And again, and I don't mean to be rude, I mean to be crude, but I don't mean to be rude. Think of Big Pharma. Yeah? What's their bottom line is how much profit can I make? If you turn around to them and say, you don't have to spend £1 million a year on animal experiments, here's a couple of $100,000 to do this non-animal thing, they'll go with the non-animal thing because that's extra profit for them. This is the big thing for us, poor human relevancy. Yeah? Animals are not good humans. Yeah? Is the bottom line. So there are cases out there that in which drugs that don't work in animals might work in humans. But we don't know that because it fails in the animal study. Yeah? We all know the flip side. They've done the animal experiments have worked, a new drug, all of a sudden it's withdrawn off the market because of adverse effects, because of side effects, because of things. But hang on, we've got to remember at that point, it's already been through the animals have been fine with it. Yeah? The big classic example that most of you might remember is a couple of years ago at Norfolk Park Hospital, the TGN 1412 trial. Yeah? There were lots of reasons why that trial went horribly, horribly wrong. But the take home from that was all the animal experiments that they'd done had gone, this is fine, this is great. And so therefore they put it in humans. But let's think of the flip side to that. What if it had gone really badly in the animal studies? And they'd gone, oh no, we can't put this in humans because it's killing the animals. How do we know it wouldn't have been great for humans? Now, if there's no human relevancy to that test you're doing, apart from does it kill the animal or not, then how do you know if it's useful for us? And that's where we are at the Dr Hadwen Trust. So just to quickly touch on the ethical issue, because we're all here as highly ethical people. Yeah? The animal rights thing is a big thing for us because it changes. The ethics behind the animal use changes. Who decides what's ethically right or wrong? What people 15, 20, 30, 40, 100 years ago thought was okay to do with animals, we wouldn't do now. None of us would do now. Even if we were allowed to do, you wouldn't do it. So the goalposts change. Well, if the goalposts are changing, how can you rely on that test then? How can you rely on that as your avenue to do your research? Yeah? Is it the issue, is it the ability to feel pain? Is it the ability to feel suffering? Because again, that changes. More and more and more people are finding out, scientists are finding out by doing the experiments, but they're finding out that more and more animals feel pain, can suffer. For many years, people thought fish don't feel any pain. So when you go fishing, it's okay for you to use the hooks because you just take it out, throw the fish back, and it's fine. It doesn't feel that pain. But now, the research is that they feel something. The more you research into it, it might be that they feel pain. All of a sudden, hang on, we can't do any fishing because fish feel pain. Octopuses, for years weren't on the list of animals that you couldn't experiment on because people always thought octopuses don't feel pain. All of a sudden, research came out, octopuses do feel pain. Now you can't experiment on octopuses without a license. The goalposts always change. The ethics behind it always changes. And again, are some animals of a lesser worth than others? We've just had the talk, and you guys already know about all souls are equal. Yeah? It's not the prevailing view outside, but lots of people think that they're lesser worth. Even the Home Office classifies animals differently. Anything higher than a mouse, Any mammal higher than a mouse, you need a license to do that. Anything lower than a mouse, so things like worms, nematodes, flies, fruit flies, we've all seen them buzzing around, all that experimental work, don't need a license to do that. So even the government thinks that there are animals of lesser and higher worth. Now we don't know, no one's done the research. Does a fruit fly feel pain? Does a spider feel pain? Does a worm feel pain? We know that when you're kids, when kids are messing around with the worms in the garden, we know that if you shine the magnifying glass on them, if you put them somewhere else, they will move away from it. So is that pain or is that something else? We don't know. Yeah? But there is that thing. And again, finally, our understanding and awareness of sentience has changed over time. You know, the animals we think are just animals, and the animals we think of more than just animal behaviours. Yeah, it does change. So the ethics behind animal use changes slightly. And so as the Dr Hadwen Trust, one of the things we do is say, let's focus on the science behind it. Show us that the science holds up, and that's fine. Yeah? So just to put some numbers in context, I just want to show of hands. Does anyone know roughly how many animals were used in the UK in 2015? Can anyone guess? 4.1 million. Someone's been looking on our website. No, fair enough. It is. No, it is 4.14 million procedures. Now, what a procedure is anything that you do to the animal that is equivalent or more than sticking a needle in them, giving them an injection, is a procedure. So just how we would go to the doctor to get flu jabs, just injecting an animal with that is a procedure, and it's counted. Yeah? It's not just the cutting open their skulls and sticking electrodes in and mushing things around. That's probably several procedures. 2.06 million procedures were to produce genetically modified animals. So about half of all procedures that take place are just breeding genetically modified animals. On top of that, 2.08 million were what we will call actual, real procedures. Yeah? And then just some top-level numbers in terms of the number of animals. There are a lot more than this, but about 2,200 non-human primates, about 200 cats, about 3,500 dogs, 265,000 rats, and then the majority of animal experiments is mice. Yeah, it is mice. Yeah, 3 million mice were used. And then one of the, sorry, yes?
Did you say it's all for the UK?
That's just Great Britain. Not, sorry, we say UK, but it's just Great Britain, so it's England, Scotland, and Wales. That's it.
Can I ask the kind of the swim test on rats, would that count as a procedure? Because you're not...
That's a single procedure. The rat swim test would be a single procedure because the animal can experience pain and suffering. If the animal doesn't experience pain and suffering, it's not a procedure. So, yeah.
What's the reason why there's so many mice? Like, is there like,
because they're very easy to use and manipulate and do things with. To cage, to look after a non-human primate, you would need a facility, you would need them to house them in a facility this size, sort of thing, to ensure their welfare. Because again, going back to the Home Office, the rules and regulations, they need to be in an environment that they're comfortable with. A mouse you can put in a shoebox, and they're happy in that environment because they're used to burrowing and scurrying. So in a room this size, you could look after, you could keep 10,000 mice, but only one primate. Also, it's very easy to look after mice. It's very easy to breed mice. You've already got the facility set up. You don't have to do anything extra special with them to set it up. Like I say, I'm being very crude, it's not how it is, but you can put them in a shoebox and put them on a shelf. And then every few hours open and close the door to give them the sunlight. And they're happy.
Post-procedure, are they destroyed or do they live again and have another experiment?
90-something% of them, probably 95 to 98% of them are destroyed. You do the experiment, once you're done with that animal, it's put down, it's euthanized, and it's then destroyed. That's the reality of it. Because what happens is you've done an experiment on them, whatever that experiment is, those animals are no longer virgin in that sense. Something's happened to them, so if you do something else to them, you can't guarantee that the second procedure you've done to them is not directly related to the first procedure, or whether it's just because of that procedure you've done. So they're a bit of equipment, to put it in the crudest sense. They're something you use and throw away, just how we would use disposable plastics. You would you grow them, you breed them, you do experiment on them, and then you would get rid of them. So 99%, probably 99% to be honest, because nearly every single one of those mice would have been destroyed at the end.
What about research on like cosmetics? Is that counted as a procedure? Or?
In the UK, you cannot do cosmetics experiments. There is a blanket government ban. You cannot test cosmetics on animals. You can't even test now. Just 2014, I keep saying last year, but the years are flying by. 2014, they also introduced a ban on household products. So all the stuff that's in your shelves at home to clean the houses with, you can't test those on animals as well. That's not to say cosmetics aren't still tested on animals, but just not in the UK. For example, I'm allowed to say this because that's what it is. China still requires animal testing for cosmetics. So even if the product has been created in the UK, it's been approved in the UK, it's on the shelves, and I'm not going to pick on any brands, but if it's in the UK and it's on the shelf and you can buy it, in order to sell it in China, you have to do the animal experiment in China. It's just the way the world works. We're mad humans. But there is a lot of work, there is a lot of work to unify everything so that if it's already been approved in the UK, it should be approved in China. But people like to play the big man.
Was that not Europe-wide though?
The cosmetics ban is Europe-wide, the household products ban is Europe-wide. Post-Brexit, I don't know what's going to happen now. I think every talk anyone else says post-Brexit, I don't know. But again, there is an issue because a lot of the rules and regulations that surround animal work have all come from European directives. It's all come from Europe. Although the UK is the leader and Europe picked up on a lot of the work that we did and put it into the directive, now it's all gone. Well, who knows? They could technically, in theory, they could turn around and say, right, we don't like this anymore, let's go back to how it was 100 years ago. They could do. But yeah, cosmetics throughout Europe and nearly America, I can't remember 100% off the top of my head. India has banned it. In India, you cannot test cosmetics on animals in India. And there are a few other countries as well, Australia and places. Cosmetics are no longer tested on animals, but there are lots of ways around it. There are lots of very smart people in industry who can get around it, but that's a discussion we can have separately. But there are ways around it, but in essence, the cosmetics you buy now shouldn't have been tested on animals. But that's not to say that your branded stuff that is already available wouldn't have been tested on animals, because they would have been tested on animals years ago, because they're already out there. It's anything new that comes out from now hasn't been tested on animals, and that's the important bit. But there is always the Leaping Bunny stuff. The Cruelty Free International, the BUAV, they certify a lot of current products as being cruelty free, having not been tested on animals. So always look out for the Leaping Bunny logo as well when it comes to cosmetics. And for the gents in the room, I should just say, a lot of the Superdrug's own brand stuff is all cruelty free.
And vegan.
No, the ladies will always want expensive stuff. So, yeah, and then one of the good things that they have done in the last couple of years is they actually talk about how bad were the experiments, how severe were the animal experiments. So there are different levels, and they all have to be counted, but we've never known up until now how bad they are. Is it that every experiment that's taking place is severe? And severe meaning we kind of know what severe means. Mild means is equivalent to the injection scenario I was talking about. That's mild. So you can imagine what severe is. But are all animal experiments severe, or are they all mild? Or we didn't know. Even as the Dr Hadwen Trust, we didn't know. We weren't allowed to get that information, but they have been publishing it. And so just like I said, for your information, 13% are sub-threshold. So there were experiments that took place that they thought might have been mild, but weren't mild. And there's a lot of reasons for that. 6% were non-recovery. Non-recovery means the animal is given a general anaesthetic So it's knocked out, it's given a general anaesthetic, you then do all your procedures on it, and the animal never wakes up. Yeah? So there are those experiments. They can be severe, but they're classified as non-recovery because the animals are knocked out from the start. Yeah? That's not to say that they're good, but they are. Half of the procedures are mild, equivalent to having an injection. 24% are moderate and 6% are severe. And the different levels within there are huge, so it's always to know. But it's just something to know that half of all experiments that take place are of the mild category, and they have to report these things now. If they don't report these things, the Home Office comes down on them like a ton of bricks. So they have to report these things. But what do those numbers mean? It means 11 and a half, roughly, 11,300 procedures per day, every day last year took place. And then you think half of those were just breeding. So every day they bred 6,000, roughly 5,000 to 6,000 animals, mice, rats, cats, dogs, everything. Every day. As we're talking here, animals are being bred. Yeah? That's the scary thing. That's the bit that sends shivers down my spine. That even as we're talking here, these things are happening. Yeah? And it's a sobering number, that is 11,350 a day last year. So if we look at the historical trend in terms of animal use, this is Home Office statistics, these are government statistics, in the last 10 years. The black bar is what we would call proper experiments, actual experiments. The white bar is the breeding. Yeah? And as you can see, over the last 10 years, the amount of breeding is going up. Yeah? It's got towards 50%, and it will get higher, and there's a lot of reasons for that to do with the genetically modified stuff. Creating genetically modified animals takes a long time, and it takes a lot of animals. And one genetically modified animal cannot be modified again to make another genetically modified animal. Then you've got to keep them, like I said, you've got to keep them clean, you've got to keep them pure. But as you can see, we're kind of there, sort of about the 4 million mark for the last few years. Yeah, it's a lot of animals. A lot of animals that are being used. But one of the things I have to mention, if you go away and do some more research, the way they counted the animals changed in 2014. So the way we count the animals changed, so it's got a little bit difficult to compare, but you can do, so that's why there's a drop there, but there's a reason for the drop, because the people that were giving the numbers in got it a little bit wrong. And I know that because we went to the meetings and they told us it's okay to do the same. They got it a little bit wrong, so that looks great. Oh look, it's gone down by, I think it was 8%. I think that's about an 8% drop. It looks great, but unfortunately they just couldn't count it. But that's what it is. This is the important bit. Yeah, lots of people will say animal research is the gold standard. Now, what does that mean? We know when we talk about in the Olympics, let's talk about the Olympics because it's just happened in Paralympics Games. Going for gold means it's the best. You are the best. You are the greatest at what you do. Animal research in biomedical research, well, we've just talked about all the different things that change, all the variabilities, all of that sort of stuff. So if the goalposts keep changing, how is that a gold standard? Yeah, if someone said to you, this is the gold standard, this is not a gold standard talk, but the one before was a gold standard talk. If I say that's the gold standard talk, and then someone turns up and says, oh no, but you've got to do it this way now, you've got to do it that way now, and you change the gold standard, how is that a gold standard? Yeah? So traditionally, people have always gone, animal research is the gold standard, but it's not. Yeah? And it's okay to go out there and say that. You can say, Alpesh said it, it's not, it's fine. Yeah? Animal research is not the gold standard. And that's that mind change we need to do, that shift in our mindset that we need to do. And it's hard. If you've built a career up, you might have been a researcher for 20, 30, 40 years. You build a career on doing animal work. For then yourself to turn around and say, oh no, I'm just going to disregard the last 20 years of my research, 30 years of my research, and do something else. It's difficult. It's hard for all of us in our normal jobs. So if you're doing something one way and someone turns up to you and says, you've got to do it a different way, it's difficult. So we need to bear that in mind. But it's not the gold standard. There are ways of doing things that are different. So, what do we do as the DHT? What do we do? What is it? Why do I get paid to go into work every day? We fund replacement research. We fund research that replaces the use of animals. Just to give you some very top level facts and figures, in 2014, we had 22 research projects that were ongoing, 22. Yeah? Now, some of you, I'll say that later. In 2015, we funded a record 14 summer studentships. And summer studentships are all about getting young people, undergraduates, people who are at that early point where we can influence them to get them doing non-animal research rather than going in and saying, let's do some animal stuff. And then so far this year, and I say so far because I'm not allowed to say something, we've funded 12 summer studentships and 6 summer fellowships. Yeah? We have already had a project up in the University of Dundee using human cadavers to do lots of medical device testing. But we've now extended that. We're doing a follow-up 5-year grant with them to extend that project because it's been so useful to us, it's been so good to us. It's using donated human bodies, but you embalm them. For those that know, when you embalm a body, it goes very hard and rigid and it also smells. And now you're not allowed to use formaldehyde because that's a carcinogen, that causes cancer, and you can't do all of that sort of stuff. So you can't use normal dead bodies in that way. So this technique's been invented in Germany, and this group in Dundee is one of the first to use it in the UK. But they use this special chemical called teal. It's a cocktail they use. But it keeps, and I apologize, I'm glad there's no food. It keeps their bodies all floppy and squishy. So in essence, how our bodies are now, those bodies remain the same way once they're dead. And so you can still do that. Now I think if you're looking at heart pumps and you're looking at stents and you want to test a new type of stent, you need to be able to do it in a what they call artery, not the word, in an artery that's flexible. If you do it in a hard bit of plastic piping, is that really human? So going back to the human relevancy, teal embalmed cadavers are more human relevant than normal cadavers. Yeah, and that's where the human relevancy. So far, and there is a few other things that we will be announcing, so keep your eyes peeled to our website. We also promote, we don't just fund, we promote. Yeah? We do lectures and conferences. We now have our own annual conference where people come and they talk about the latest research that goes on. So in 2014 was our first one. Last year we talked about fundamental biology in the 21st century. People turn up saying, this is the cutting edge research, let's share that with the world. Rather than keeping it all to myself, like, this is mine, this is my precious. Yeah, none of that. This is, let me tell you what I'm doing, let's spread that as much as we can do. We publish lots of things. We also talk to the media as much as possible. Yeah, unfortunately, we're not very shouty. Yeah, it's very easy to be shouty. Yeah, we're not very shouty, so lots of people don't come to us, they want to go to the shouty people. But that's okay. But we do as much as we can, we try and get into as much scientific publications and scientific media as we can. We also engage with stakeholders, people like you. We get involved with the government. Yeah? There's no point standing on the outside going, stop all animal experiments. You've got to get in there and engage with these people. Be the positive change. We worked very closely with the European Union when we were updating all the directives about animal work. And again, we go to a lot of scientific conferences, and then we also come to see wonderful people like you as well. Why do we fund the research? I think that's fairly obvious why we fund the research. Now, it's all the ethical questions, but we are about the ethics, but it's not our main reason. Yeah? It's about, especially when the animal-derived data has questionable translatable value. I've done loads of animal experiments, but I'm not quite sure how it relates to the human condition. Why did you do the animal experiments then? Yeah, when it's not translatable, it makes us even madder. Yeah, you've done it, okay, you've done it, but then if you can't relate it to the humans, why did you want? There is a public perception about animal experiments. Like I say, most people think animal experiments, because of what's been put out there, is people taking rabbits and squirting things in their eyes and cutting open skulls and sticking probes in. It's the minority of, unfortunately, it is the minority of research that goes on. Most of it's mice and rats, and it is mild. We don't like it, but that's what it is. How informed are you? Do you know what goes on, or is it? And like I say, the Jainism thing, the ahimsa thing, is a huge part of what you guys believe in. But is that enough? Yes.
Isn't it illegal for people in labs to tell people what goes on?
Yes.
And they're up to 2 years in prison.
There is a huge problem with the regulations as they stand, and it's a thing called Section 24. Section 24 is a clause in the law that says you cannot tell anyone what you are doing. In essence, that's what it is. So So even if you're very friendly with an animal researcher, yeah, they cannot tell you legally what they are doing, which is why we couldn't give you the numbers we could give you. We can give you the numbers going back to the 1960s. But the severity thing, no one could tell us because they weren't allowed to tell us. They've changed it now, and there is we're in huge consultation at the moment with the government about changing that and making it a little bit more open, but we just don't know. We don't know what animal experiments. I could not tell you, hand on heart, I could not tell you a single experiment that took place in 2015 that used animals. We're not allowed that information. Section 24 binds our hands, binds the government's hands, binds the researchers' hands. And they do. Whistleblowing is a different issue, but if someone goes out and says, hey look, all this stuff is going on in our labs, they go to jail for it. Yes?
So how do they report the results in scientific papers?
They can publish in scientific papers, and that's different because that's not, unfortunately, those papers, you can't correlate them back to a particular year. You can correlate them back to a particular location and a particular place, but a paper that's published this year, unfortunately, that animal experiment could have taken place 3 years ago. It's not, I've done this experiment today and I'm going to publish tomorrow. Yeah? Publishing can take up to a year, year and a half. From sending in a manuscript to say, here's some research I've done, please publish it, to the journal going, all right, let's publish it, and then people actually being able to read it can take up to a year, year and a half. Yeah? So yes, once it's published, we know it's happened, but that's historical in that sense. It's not, we don't know when that experiment took place, because we don't know when those cats, dogs, rats, mice, whatever those animals, when they were used. It's changing a little bit. Section 24 is, like I say, being worked on, and we're trying to get rid of it as much as we can, but it's getting better, but we're not quite there yet. Yeah? The other thing is replacement technologies to be used when available. Scientists are busy people. They spend all their working lives trying to keep up with the latest in their field of research. It's very hard for them, and I'm not scapegoating them by any means, but I was a scientist. I was in the lab once. But it's very hard to just keep up with my area of expertise, never mind anything else that might be going on. So sometimes the replacement techniques are out there, they're just not that well known. And so as supporters, as stakeholders, we're not saying you need to go out there and say there is a replacement for everything, but it's to make people that might be doing animal experiments aware that have you thought about, because plant the seed. If you plant the seed, at some point they might think about, is there a better way of doing this? Is there another way of doing this? If my animal experiment isn't working, can I then go away and spend a couple of days trying to get that non-animal technique? Also, there's a thing about doing suffering is minimized. Yeah? Minimizing suffering, there's a huge thing about the 3 R's. Not reading, writing, and arithmetic. But in animal research, there's a thing called the 3 R's. Reduce, refine, and replace. It's called the 3 R's. There's a national body called the NC 3 R's that deals with all of that sort of stuff. But the aim of the 3 R's is to reduce the number of animals that are used, to refine the animal experiments, that it's the minimum amount of suffering, and then to replace them. And lots of people think that's a 3-step process. You reduce it, you refine it, and then you replace it. No. Reduce and refine are great because that deals with animals. It doesn't automatically then follow on to replace it. Because once you've reduced the numbers to the bare minimum, and once you replace them, you refine the experiments, so it's the minimum suffering, people go, hey, that's great, look, it's the least number of animals, and we're causing the least amount of harm. You don't then take that logical step and say, well, can I now get rid of them? Because you now sort of refine your system. You've got it optimized to do the thing you want it to do. So the reason why we only do replacement is because lots of people think it's a 3-step process, but it's not. Replacement is not the logical end of what's doing. And then again, like I say, it's only when the use of animals is clear benefit to biomedical research, and I think we sort of touched on that already. So what we do and why we fund it is the focus should be on the development of more relevant and reliable non-animal research methodologies. Let's give the money to the scientist who can say, I can develop something that doesn't use animals. If you can do that, then no one needs to use the animals, no matter how good the animal experiment is. If you don't need to use animals, you don't need to use them. So why we do what we do, we've covered a lot of this, so I'm not going to talk about a lot of this stuff anymore. Is the animal model valid? Is it or isn't it We say no, it's not. It's not a valid model for human relevancy. Disease induction. Now, the way to induce disease in animals is you inject them with something. To give them cancer, you take cancer cells and you stick it in the animal. Hey, the mouse now has cancer. That's not how cancer works, that's not how cancer happens. Or give them a very high dose of something that's cancer causing. That's not how cancer works, it's very small doses. Lots of the time it's done artificially. So it doesn't accurately reproduce what is clinically seen. And the clinicians out there will go, the way you see things clinically is completely different. Yeah? So human relevancy. Is the way you're causing cancer in the animal human relevant? No, it's not. So then don't do it. That's what we say at the DHT. And then genetically modified mice don't provide full solutions either. You change one thing in a mouse. Is that still the same as a human? Well, no, it's still a mouse. Yeah? And a lot of people say, and this is the thing, a lot of people say, oh, but animals are very similar to humans, that's why we need to do experiments on them. Well, why are you changing them to make them more human then? If the animal is already very similar to a human, why are you trying to make it more human then? Why not just use a human where you can? Yeah? That's why there's a huge amount of GM going on at the moment, because they're trying to humanize the animals. They're trying to make them more human, to make them more human relevant. No, don't do that. Do something else. And there is, this is a whole other lecture that we can talk about. There's a lot of poor design. There's a lot of poor reporting of animal experiments. There are huge things called meta-analyses and systematic analyses going on, where people are saying, we can't reproduce the paper, like my friend over there was talking about, the paper that's come out that says, we've done this in half a dozen mice and it's shown that this is the cause of Alzheimer's. Someone else tries to do it, you can't reproduce it. Because the way they've talked about it is so bad that you can't reproduce it. Well then, that means you've done the experiment, you've reported it badly, no one else can do that experiment to reproduce it. Now how do we know that what you've done is valuable? We don't. Yeah? So there's a huge amount of stuff at the moment like poor design, and also it's a waste. If no one else can reproduce the animal experiment you've done, no one else is going to use that data. No one else is going to follow on that. It's a waste of an animal. They've done the experiment, they've got some data, they've written about it badly, so no one else can use it, no one else is going to follow up on that. Human relevancy, we've already talked about human relevancy. I'm not going to spend too much time on this one, I want to spend more time on this. Yeah? Eron's law. Now, Eron's law, lots of people have heard about Moore's law. Yeah, hands up if you've heard of Moore's law. Moore's law is this whole thing about computers that every 18 months or so they double in speed and the number of processors double, so that things get faster and better and more efficient. Well, Eron's law is something in science. It's the observation that drug discovery is becoming slower and more expensive over time. Even with all these new technologies, even with all these genetically modified stuff, even with all this technology, thousands and millions of people working on it. Eron's law is drug discovery is becoming slower and more expensive. What they found is the cost of developing new drugs is doubling every 9 years. It's not coming down every 9 years, it's doubling every 9 years. Yeah? And again, so what's happened, that's why it's called Eron, it's Moore's law backwards. Yeah? Instead of getting faster and more efficient, it's getting slower and less efficient. And this is a paper that came out in 2012 talking about pharmaceutical R&D. Yeah? And this is the number of drugs that the FDA, unfortunately, we don't get that data here, but the Americans are quite good at this. The FDA, this is inflation-adjusted spending in billions. Yeah, in billions, not millions or thousands, in billions per year. And this is the graph. You don't need to look at the data, but it's quite clear to see that's not good. Yeah, this is drugs per billion, and this is year across the bottom. And as you can see, over time, the number of drugs that are being approved every year is going down. Then you adjust for delays and you look at the rate of decline and all of that sort of stuff, and we have passed the point of 1 drug per billion. We've way exceeded that. We're down near we're coming close to the 1 drug per $2 billion of investment. So from start to finish, $2 billion to get 1 drug out. And after that, 6 months later, there might be a whole load of adverse drug reactions and a whole load of side effects, and they pull it from the market. It's where we are with the state. Human relevancy. All of this work means that something's going wrong in the pipeline. At some point, this pipeline is broken so that all of this money that they're putting in isn't working, isn't human relevant. And this is all down to human relevancy. This has got nothing to do with animals. It's got nothing to do with non-animal or animal. This is just the pipeline that they have is broken. And where is it broken? Well, you can create 10,000 drugs in an afternoon now. There are machines out there that you put chemicals, a whole load of chemicals in at one end, and at the other end come out all these different combinations. It's not developing drugs, it's finding out where they work or whether they don't work. That's the blockage. Because they're doing this animal stuff, and they're saying it's failing in animals, or it's not failing in animals, and then it goes on to human clinical trials, then it's failing in the humans. There are 10,000 drugs, going back to this. 1 in 10,000 new chemicals gets to market. They will create 10,000. So there are 9,999 chemicals that they say don't work in humans. How do we know this? They've done the animal experiment. A lot of them won't. A lot of them will be toxic to humans. I'm not saying all 9,999 will be relevant to humans. But something in there is toxic to the animals, but possibly not toxic to humans, and it's getting dropped. Yes?
Has this failure rate changed over time? How was it like 40, 50 years ago?
I don't have those numbers to hand. I would assume the failure rate is going up because of all the computational and all the chemistry that they can do now. So 50 years ago, to make 10,000 chemicals probably would have taken them a long, long time. So they probably wouldn't have created that many chemicals. They probably would have started with a few from nature and modified those, but now they can do what they call de novo synthesis. They can just take the raw, just like we make a cake, they take the raw ingredients, put them together and see what comes out at the end. So the rate of failure is probably higher, but because they're creating a lot more chemicals to try and get them to work.
I just add, a lot of them don't actually do anything.
Yeah, no,
So
totally.
it's not that they're toxic, they
Yes,
just
they
don't
don't-
do
they
what
don't work.
they want them to do. So they are easily
Yeah,
discarded. And,
there's probably 80–90% of that they discard straight away because they don't work.
and that test can be done in laboratory conditions even without often the
Yes.
use of any
Yeah,
animals.
no, totally.
So only about, let's say, 5 to 10% are potentially able to work and that could go. The other thing I would say that the cost is because the regulations are much stricter now than they were 50 years ago. Case in point, things like thalidomide, the structures in place to test drugs, and the time it takes, 10 years sometimes, of testing and
10
trials,
years, yeah, 10
and
years is a good
human
time.
trials as well. So,
Oh no, there is. No,
you know,
I'm not
I'm just
stating
trying
it
to put it in
Yeah.
context.
No, totally. Thank you very much. No, I'm totally not saying this is all down to the animals. This is just the state of play as it is now. Sorry, say.
Yeah, one question. Talking about this 10,000 chemicals, is this about single active compound,
No.
or is it combination?
This is combinations of everything. This is just let's create a whole load of stuff, see if it works. A lot of them won't work. The one active chemical might be just the one. So then it will just be the one. So again, like I said, one of the things that we say at the Dr Hadwen Trust is we need the efficacy, whether it works or not, whether it doesn't work. We need the safety. It needs to be reviewed because there is an issue with it. Yes, there is a lot more drugs coming out, and a lot of them don't work, and a lot of them are never going to work, and for various different reasons. But are things falling through? And I don't like to use the example because it's a very historical one, but it highlights the point about penicillin. It's not, but it's the easy one. Penicillin, if they tested penicillin on guinea pigs, never would have come to market. Because penicillin for guinea pigs is toxic. It will kill them. The smallest dose of penicillin will kill a guinea pig outright. So if they'd done the animal experiment, this is why I don't like it, because when penicillin was discovered a couple of hundred years ago, it was just stick it straight in the human. There was no ethical reason about it. But if they'd done the animal experiment on penicillin, we wouldn't have penicillin. And how many of these chemicals they're doing now might be doing exactly the same thing, I don't know. There are a lot of clever scientists out there doing a lot of computational stuff to try and work it out, but as it stands, we don't know. Well, I've already talked about this is the machine. You stick your head in this machine and it measures the magnetic and electrical activity in your brain. It's amazing the way it can do it. But it's liquid helium core. Yeah? And it's in a room that has 2-foot concrete walls and it's shielded because you can't have, you have to isolate the room from the Earth because of the Earth's magnetic field. It's about 10,000 or 100,000 times stronger than the signals that they're trying to pick up. So this room, when the door's closed, isolates you from the world and all of its magnetic fields. It's phenomenal. But just think, to set that up, how much would that cost? So it's difficult for someone to come, well, can we do brain studies? Yeah, but we've been funding these guys for years now, and it's phenomenal. We've developed a 3D model of breast cancer. So rather than having to put breast cancer and study that in animals, usually mice, we funded a project that's developed a human 3D model. So you can now grow up little tiny breast cancers in a petri dish, and you can do all your experiments on that instead. Lots and lots of words. It's a breast cancer model. And then this is the big one, the rabies vaccine. It's one of our most recent success stories. So rabies isn't a problem in the UK, but it's a huge problem in the developing world. And unfortunately, like I say, we're very great in the UK. We have high animal welfare standards. We do everything properly. But to produce rabies vaccine, you have to get it from horses. But you go out to the Far East, you go out to the developing countries, who can afford to look after a horse to produce rabies vaccine? So they do it very, very dodgy. They do it very illegally. So what we've been funding is a project that's producing rabies vaccine in plants. And the idea is, just have farmers produce crops. The farmers in these countries would just grow these tobacco plants. They are tobacco plants, so we're finally putting tobacco to good use. Yeah. But in essence, what they've done is they're now producing rabies vaccine in plants. Now, who can't grow plants? Most people can. Most farmers will know how to grow plants. So it's a much cheaper way of doing this. Yeah? And now what they're trying to do is they're trying to turn it into some hydroponic robotic system where you don't even have to deal with the plants. The plants just literally secrete rabies antibody into the hydroponic medium, and you can just hoover that all up, and then the robots will do it. So this is a cheaper, human-relevant way of producing vaccine. And there is a video on this. I'm not going to talk about this too much. Yeah. So are we there yet? Have we replaced the use of animals? Unfortunately, not. We have a restricted number of methods. Yeah. They do need validation. They do need approval. They need to be approved scientifically. There's no point us funding research if the scientific community goes, that's rubbish. Because if the scientific community goes, that's rubbish, no one's going to use it. So it needs to be approved by the scientific community. Lots of things need to be approved by regulators. They also need to be approved by other countries. Like I say, I mentioned the China cosmetics thing already. One of the drawbacks to doing non-animal stuff is you look at things in isolation. If you look at things in isolation, it leads to differences. So going back to the organ on a chip, the human on a chip, some of the omics technologies, it's trying to bring all of that, trying to produce all these things that interact with each other to make it more human relevant. And unfortunately, current regulatory legislation and system testings, and I'm going to take 2 minutes out here, I'm nearly finished, 2 minutes out just to talk about drugs. Now, we have this ethical dilemma about drugs. Have they been developed on animals, have they been tested on animals? I can't tell you, because we do get a lot of phone calls from people saying, my doctor has prescribed this drug, can you tell me if that's been tested on animals or not? The answer is, if you can get it in a pharmacy, if you can get it on the NHS, if it's a prescription drug, it has been tested on animals. That's the law. And it has to have been tested on at least 2 species of animal. So it's usually mouse and dog. Yeah? That is not to say, though, that the drug has been developed in animals. And there's a difference between the two. From discovery all the way to regulatory approval could have been done without animals. I can't tell you if there are any drugs that have happened because it's all proprietary and the companies don't release that information, but the development of a drug can take place without animals. But to get it on the shelf, you've got to do the 2 animal tests. So from a HIMSA point of view, from a Jane point of view, you have to make that choice. But in essence, if you go to the doctor and he prescribes you something, at a minimum, it would have been tested on 2 animals in order for it to be prescribable. So the history of the drug, we're never going to know. How it was developed, how it was approved, we're never going to know. Yeah? And I have to tell you guys that from now. Yeah? There's no, unless you can go into that company and get that information, we don't know, unfortunately. But that's not to say that the drugs you take have been tested on animals. They've only been tested on animals at that very last regulatory step. So if we can change that regulatory step, if we can develop the alternatives, the non-animal technologies to say you can do 20 tests that are human relevant and will prove that this drug is safe in humans, then we can drop the regulatory test. And we can drop the animal test right at the end. So, it is time for a change. There is a shift in mentality out there about change. There was a letter in the BMJ, a lot of people may have heard of the BMJ, the British Medical Journal, talking about what can we do differently to the animal experiments. So we put in a response to that, we put in a letter to the BMJ that got published. In essence, what we're saying, it is time to change. We're at a point in our scientific development as a society where we now can no longer say there is no alternative. Yeah? And what we've done is we've called on the government to take the lead. 20 years for cosmetics regulation. If they say from now we want to ban the use of animals in biomedical research, it might take 20, 30, 40 years, but we have a goal. At the moment, we don't know where the end point is. We don't know where the finish line is. So we're calling on the government to do something about it. Yeah? So, the solution is replacement funding. It's government funding in the 3 R's. It's legislation. Like I said, the law has changed. Now, when there's a scientifically valid non-animal method, you have to use that instead of the animal method. Yeah? And that's a huge change for us. Because up until now, it was use the animals. But now, if there's a scientifically valid method, they have to use that. And this is why, as the DHT, we want to promote as much non-animal research as possible. We want to fund as much non-animal research. Because if the MRI stuff, the MEG stuff, if we can say, look, you can look at brain pathways, you can look at how the brain works without sticking probes into animals. It's a scientifically valid alternative. Other people have to use it, and that's how we replace the use of animals. Yeah? We need to coordinate. This is not us working in isolation. We need to work with everyone. Yeah? My friend here works at the Francis Crick Institute. There's 1,000 researchers there at the Francis Crick. I'm not saying they're all doing animal work. Most of them aren't. But just in that one institute, 1,000 universities, we fund 22 projects a year. We've got 12 ongoing at the moment. Yeah? We've got to work together in order to make a difference. We need to phase things out. We can't just stop it overnight. And then we also need to innovate. So, what's the future? The animal replacement techniques do exist. Yeah, we need to develop more of them, but they do exist. But they don't exist for every field. They don't exist for every question that people want, scientists want answers to. Yeah, scientists aren't going to go, I can't use animals, right, I'm out of a job. Yeah, if we stop all animal experiments tomorrow, all scientists will be out of a job because there are questions we can't answer yet, unfortunately. Yeah? But we need to develop more, and we are developing more. And we're at the beginning of a journey. Yeah? It's a journey we've started many, many years ago, but we're still at the beginning. Yeah? So what can you do? You can be aware that the animals are used, and hopefully I've given you a little bit of awareness about that. Just because they have been used, they don't have to be used now. Help us on social media, spread the word. Yeah? We're not very shouty, but we love it when our supporters are shouty. Yeah? It's always good for us. It comes down to fundraising, and my colleague Kay will talk about that later. If we don't have any money, we can't fund the replacements. Yeah, we need the money to fund the replacement. And then have the conversation, spread the word of who we are and what we do. Yeah? So just to give you a thing, lots and lots of information on our website. We're on Facebook and Twitter. If you want to sign up for more sciencey news, because a lot of what's on the website is supporter-based, if you want more sciencey news, then if you go to that website, drhadwen.org/science news, you sign up for our science newsletter. About once a month we send out lots of information about the science of replacements, what the latest in replacements is. So thank you very much for listening to me. Thank you very much for having a discussion rather than having a one-way. I apologise for being a little bit over time, but I am around if anyone has any questions now or later. please feel free to chat. Thank you very much.